Today we're going to look at the definition of stoichiometry, and then we're going to solve some problems using stoichiometry. So what stoichiometry is, the definition is calculations based off of the reactants and products on a balanced chemical reaction. So the reason we've been learning, first of all, what a chemical reaction is, but also how to balance chemical reactions is to lead up to this point. So now, based off of this balanced chemical reaction, we can calculate any of the reactants or any of the products we want. Okay? And the reason that we can do this is because the coefficients, they represent the number of moles. And we know how to calculate moles. We know how to go from moles to grams. We know how to go from moles to atoms, moles to molecules. We know how to do all those calculations. Now we can apply it to a balanced chemical reaction. Okay, so when I say coefficients, I'm talking about the numbers before each of those elements and compounds. The numbers that we change when we balance a chemical reaction. So let's look at what type of problem we would be asked given this balanced chemical equation. So the problem we're going to look at first is how many moles of O2 are needed to produce 5.4 moles of aluminum oxide, so of product essentially, right? Because we have the reactants over here, and then we have an arrow pointing toward the products. So what I'm going to start out is I'm going to write my steps. So I'm starting right, with 5.4 moles of product. That's how much I want to produce. Then I'm going to go from moles of product, moles of aluminum oxide, to moles of oxygen. Okay, so starting at moles of product, and I'm going to go to moles of oxygen. So I can do this because these coefficients in front of all of these elements and compounds represent the numbers of moles. So what I'm going to use to go from moles of aluminum oxide to moles of oxygen is that mole ratio. All right, mole ratio here. And what mole ratio am I using? Well, I'm going between oxygen and aluminum oxide. So I'm looking at a 3:2 ratio. So over to the side, I'm going to write that ratio. So ratio needed. I have 3 moles of O2 is going to equal 2, since that's the coefficient in front of aluminum oxide, moles of aluminum oxide. So notice this looks like a conversion factor, and that's exactly how I'm going to use it. I'm going to use it to get from moles of aluminum oxide to moles of oxygen, which is what the question is asking for. So now that I have my conversion factor, I'm going to start my railroad tracks. Okay, my railroad tracks, what am I going to put in this upper left-hand corner? The piece of information given to me in the question, so that is going to be 5.4 moles, and I'm going to write moles of what? Because we're going between different elements and compounds here, so I want to keep track of exactly what I'm talking about. So I'm going to put moles of aluminum oxide. Because when I use this mole ratio, that will help me figure out what goes on top and what goes on bottom. Because I need to cancel out the moles of aluminum oxide. So that means I'm going to need to put this 2 moles of aluminum oxide on the bottom. That way, moles of aluminum oxide, cancel. That's going to put the 3 portion on the top. It's a little bigger than I needed. All right. So now I calculate. So let me grab my calculator. Oops, moving the board. And we're going to do 5.4 times 3, and then divide that by 2. And I get to 2 significant figures, because that's what I have in my original problem. I get 8.1 moles of oxygen. So what this is saying is if I wanted to make 5.4 moles of product, the aluminum oxide, I would need to put in my flask at the beginning of the experiment 8.1 moles of oxygen. Okay, and since I know how to calculate grams per moles using molar mass, I could even take this a step further and figure out how many grams of oxygen I need to put into the flask. So that's how we're using stoichiometry. So this is just a one-step problem. So let's take a look at a larger problem with more steps and see how that goes. So the next problem we're looking at, what mass of aluminum is needed to produce 7 grams of aluminum oxide? Okay, so this is a stoichiometric problem because we are going between aluminum, Al, and aluminum oxide. So whenever you're going between two different elements or compounds, you need a balanced chemical reaction in order to solve that. All right, so this time it's going to take a few more steps because notice we're starting in grams this time. So I'm going to write the steps that I want to go through. So I'm starting with grams of aluminum oxide, okay? And I want to go to grams because that's what mass is. It's grams. Write that up here. So mass is grams of aluminum. Okay, well, I can't go directly between grams of aluminum oxide to grams of aluminum. Why? Because these coefficients here, these represent the number of moles. So I need aluminum oxide in moles in order to use this chemical equation. So my first step is going to be going from grams of aluminum oxide to moles of aluminum oxide. So in order to go between grams and moles, what piece of information do I need? I'm going to need a molar mass because remember, molar mass is measured in grams per mole, so it can get us between grams and moles. Once I'm in moles, now I can use the chemical reaction. Now I can use those coefficients in a mole ratio to get between aluminum oxide and aluminum. So my next step is to go to moles of aluminum by using the coefficients. And when I use the coefficients, it's called a mole ratio. So I'm just going to write ratio here because that's what I'm going to need for my conversion factor in that step to go between moles of two different elements and compounds. Now, moles of aluminum, I don't want to stop there, right? Because the question is asking for grams of aluminum. So I have one last step that is to get to grams of aluminum. And to go between moles and grams, just like this first step here, what do we need? Molar mass. Molar mass being measured in grams per mole, which will get us between moles and grams. All right, so before I start my railroad tracks, off to the side here, I'm going to write down everything I need for those 3 steps so that it's all prepared when I have it. Okay, so my first step, going between grams and moles, I need a molar mass of aluminum oxide. So for that, I need my periodic table because I need to list all elements present. I'm going to use the subscripts to tell me how many atoms of every element are present in that compound. And then lastly, the periodic table to figure out the mass of each of those elements. So for aluminum, we get 26.98. For oxygen, we get 16. And that is going to give me 2 times 26.98. 23 times 16. So I get the molar mass of aluminum oxide 101.96. And the units are grams per mole. So that's my conversion factor. Okay, so that's the first step. The second step is a ratio. Okay, so I'm going to erase this just to save myself some room. So I get 101.96 grams for 1 mole. All right, my mole ratio section, so I'm going to write ratio here. Now I'm looking at the ratio between which two elements or compounds. So I'm going to my chemical equation to figure that out. Let's see here, it's saying aluminum, so I'm looking at this guy, and aluminum oxide, this guy. So my ratio is 4 moles of aluminum is going to produce, or going to equal, 2 moles of aluminum oxide. Okay, so that is which will get me between moles of aluminum oxide and moles of aluminum. So that's the conversion factor I need for this step. My last step then is going from moles of aluminum to grams of aluminum, so I need another molar mass. And in this case, it's just an element, so I don't have to calculate. I just look up the molar mass of aluminum on the periodic table, and I get 26.98 grams is equal to 1 mole. All right, so there's my conversion factors that I'm going to use. Now I can start my railroad tracks. It's going to be a big one. So let's start there. What am I going to need in this upper right-hand corner? What do I start with? It's left-hand corner, sorry. The 7 grams. Okay, so 7 grams of aluminum oxide. And notice I'm keeping track of what element or compound I'm talking about the whole time, because I'm going to go between 2 here. So my first step to go between grams and moles, I'm using this molar mass that I calculated over here. Do I want the grams or the moles on the top? In this case, I'm going to want the moles of aluminum oxide on the top, so that 101.96 grams of aluminum oxide goes on the bottom and cancels with the grams up here. Okay, so after this calculation, after this division, I'm here. I have moles of aluminum oxide. But I don't want to stop there. I'm going to next use my ratio to get to moles of aluminum. So I'm looking down here at my ratio, and I need to figure out what I want on top and what I want on bottom when I place it here. I'm trying to get rid of moles of aluminum oxide. So I'm going to put the 2 on the bottom and the 4 on the top. That's going to cancel out my moles of aluminum oxide. Now, if I do these calculations, I have moles of aluminum. But I don't want to stop there, because I'm trying to figure out how many grams of aluminum I'm putting in this flask so that I can get out 7 grams of product. Okay, so I have one last step using the molar mass of aluminum. So that's down here. This time, the moles is going to go on the bottom, so that they're on opposite sides of this horizontal line. Moles of aluminum will cancel, putting my grams, the 26.98 of aluminum on top. So after all these calculations, remember we're multiplying across and dividing by whatever on the bottom. After all those calculations, it will tell me how many grams of aluminum I need to put in the flask if I want 7 grams of product. So let's do 7 times 1 times 4 times 26.98. Divide it by what's on the bottom, we get 101.96 times 2. It's telling me how many sig figs are we looking at? So let's look in the original question. 1, 2, 3. Those zeros count because of the decimal. So we want 3 significant figures, and I get 3.70. So 3.70 grams of aluminum is what I'm going to want to put in that flask. And if all of that reacts, I will get 7 grams of product. All right, so let's take this a step further. I know you probably didn't know there's another step. but let's apply this now to limiting reactant or limiting reagent, an excess reagent. So we're going to look at those definitions and work through another problem applying. All right, so let's look at limiting reactant, limiting reagent. So the definition of a limiting reactant is it's the first reactant that is used up in a reaction, at which point the reaction stops. So if you've looked at any of the other videos I've posted talking about limiting reactants and limiting reagents, they often apply it to cooking. So an example of this would be if this chemical reaction was a recipe instead. And you don't even have to think of it as a recipe. You can think of it as, okay, let's say I want to make some sandwiches. I'm going to have a picnic, so I'm going to make some sandwiches. I go to the fridge and I have a whole pack of sliced cheese. I have a pack of turkey, I have a pack of ham, I got lots of lunch meat. And then I go into the cupboard and I have 3 slices of bread. Okay, so based off of all of that stuff I found, what is going to determine how many sandwiches I make? It's going to be the bread, because that's what I have the least of. I have 3 slices of bread. I'm not going to make more than 1.5 sandwiches, right? So the bread in that example is my limiting reactant, because once I've used all my bread, no more sandwiches. Okay, so it's very similar to a chemical reaction, because we're going to say, okay, if I used all of my N2, how much product would that make? Then, okay, if I use all of my H2, and I should not say H3, that's not exist, sorry about that. If I use all of my H2, how much product will I make? And whichever one makes the least amount of product, that's the limiting, because when that reactant runs out, the reaction stops. There's nothing left to continue making more product. Okay, so when you're approaching a problem like this, they're going to tell you, okay, this is what they put in the flask. These are the reactants, N2 and H2, right? They're on the reactant side of the chemical equation. So this is what's going in the flask. 10 grams of N2, 5 grams of H2. And they want to say, okay, if you put all that in, how much product are you going to make? Well, in order to figure out how much product you make, you need to know which one's limiting, because one of these is going to run out before the other one. And the one that runs out first is going to determine how much product is made, because that is the limiting reactant. So let's look. So it's the same calculations we were doing previously. We're just applying them to a new definition. Okay? So to start a problem like this, I'm going to write the steps. So I have 10 grams of N2. So I have grams of N2. Now, if I used all of that whole 10 grams, what I want to figure out is how many moles of NH3 am I going to form? How many moles of product? And I'm going to do the same thing. If I used all of the H2, how many moles of NH3? Then I'm going to compare those amounts. And whichever one made the least, that's how much product I made. The least, okay? So I need to go from grams of N2 to moles of NH3. Now I can't go straight from grams of N2 to moles of a different compound, because I need to be in moles first. So my first step is to get into moles of N2. Once I'm in moles of N2, then I can use my mole ratio, using these coefficients, right, to get from moles of N2 then to moles of NH3. I'm going to do this exact same thing, but with grams of H2. Okay, so I have grams of H2 over here. I need to get to moles of H2 first, so that then I can use my mole ratio to get moles of product. So I'm solving for moles of product in both of these, and whichever number is the least, that is the limiting reagent. Okay, so before we do these calculations, let's write the conversion factors we need and get those all ready. So to go between grams of N2 to moles of N2, what do I need? I'm going to need molar mass, because molar mass is grams per mole. That'll get me between those two. To go between moles of N2 and moles of NH3, so go between moles and moles, I need a ratio based off of that chemical reaction. Over here, same thing. Molar mass for my first step, mole ratio for my second. So what do I have? Let's write my molar mass of N2. I'm going to write over here. So I have 2 nitrogen atoms. Each nitrogen atom is worth 14.01 on my periodic table. So I'm going to get 28.02 grams per mole. Now my ratio on this side. For my ratio, I am looking at N2, whoops, right here, N2 and NH3. So it is a 1 to 2 ratio. So 1 NH2 is going to equal N2, not NH2. About that. Let's rewrite this guy. 1 N2, right there, is going to equal 2 NH3. All right, let's calculate that guy. So if I used all of my NH2, all 10 grams, let's see how much product I would make. So I have 10 grams of N2. That's what I'm starting with. So if I use all of that, I'm going to start by using my molar mass to get to moles. So when I'm using my molar mass, I want the grams on the bottom so that the grams cancel, and the moles on top. Grams of N2, grams of N2. Now I'm here. I'm going to use my ratio next to get to moles of NH3. So my ratio is 1 mole of N2, so that's going to go on the bottom so that these moles of N2 are on opposite sides of that horizontal line, and then my 2 moles of NH3 is going to go on the top. Okay, so now I'm going to solve. So let's get out my calculator, and I have 10 times 2 across the top. Divide that by 28.02 on the bottom. So if I used all of my N2, I would form 3 sig figs, 0.714 moles of NH3. Now let's use all of our H2 and see how much product would form. Okay. So to do this one, I'll do a little there. I need my molar mass of H2, which is 2 times 1.008, and I get 2.016 grams per mole. And then I also need my ratio. So let's look at the ratio. Let's use a different color. So for the ratio, we're looking H2 and NH3. So H2, so it's going to be 3 to 2. So 3 H2 will give me 2 NH3s. Start my railroad tracks. Kind of a crazy looking line. Let's try that again. And I'm going to start with my 5 grams. So I have 5 grams of H2. I'm going to use my molar mass first to get to moles of H2, putting the gram portion on the bottom and the mole portion on the top. That cancels. Now on here, moles of H2. I'm going to use the ratio then to get 2 moles of NH3. This time putting the 3 on the bottom, because that represents how many moles of H2 according to this chemical equation, right? 3 moles of H2. And I'm going to put the 2 moles of NH3 on top. This is going to cancel out my moles of H2. Doing this calculation will tell me how many moles of product I'll make. So 5 times 2 across the top, and I'm going to divide that by 2.016 times 3 across the bottom. A lot bigger number. So I get, if I use all 5 grams of that H2 to 3 significant figures, I get 1.65 moles of NH3. Okay, so how do I know which one is the limiting reactant? The limiting reactant is the one that is used up first, which will make the reaction stop. So it's going to be the smallest one. So for this answer, N2 is limiting. Because if I use all of my N2, if I use all of my nitrogen, I'm going to make 0.714 moles of product. That means once I make 0.714 moles of product, there's no more nitrogen left. If there's no more nitrogen left, I can't go on and make more product. Okay, so the N2 is limiting because once all of it's used up, the reaction stops. I have 0.714 moles of product. Now I want to point out, you have to do these calculations. You have to go to moles and compare the molar amounts. Because if you'll notice, if I read this question, a lot of people will go, oh, I have less hydrogen, that's limiting. No, it's not. Once you do the calculation, it's not, because that 5 grams of hydrogen can make over 1 mole of NH3. But there's not enough nitrogen to make 1 mole of NH3. So nitrogen is limiting because nitrogen's going to run out first. All right. Well, I recommend that you try out that practice quiz that I have in the folder with limiting reactants and stoichiometry before you attempt going to the tests. So material like this, these types of calculations will be on the exam. So they weren't on the homework quizzes, but they will be on the exam. So make sure you are doing that practice quiz. And I also have a practice worksheet, a limiting reactant practice worksheet with an answer key in the practice folder. So take a look at those. Let me know if you have any more questions or if you want me to do some more problems, and I will get a video up as soon as I can.